Welcome back, students. Let's carry on with question number 11 now. It's given that sine theta is A upon B. We have to find cos theta. We all know that sine theta is equal to perpendicular by hypotenuse. So cos theta is base by hypotenuse, everyone knows. If this is your perpendicular and this is your hypotenuse, can you find out the base? What is the base? Base is hypotenuse square minus perpendicular square under root. This would be b square minus a square. So this is your base. Okay. So cos theta is equal to base upon hypotenuse. Cos theta is equal to base upon hypotenuse. So this quantity upon the hypotenuse, which is this. That means this is going to be your answer. This is what cos theta is. All right, this was an easy question. Let's move on to the next one, which is question number 12. Now we are going to need to do some calculations to solve question number 12. Sec A plus tan A multiplied by 1 minus sin A. We will try to express all these trigonometric ratios, that is sec A, tan A, in terms of sine and cos only. That will help us simplify it a little. So let's move. Let's do that. Sec A plus tan A multiplied by 1 minus sin A. This is the expression. Sec A, how can we write sec A in terms of sine or cosine? You see, sine, cos, tan, cot, sec, cosec. So sec is basically 1 upon cos. What about tan of A? It's sine A upon cos A, isn't it? And we have an extra term multiplied with this quantity. Let's simplify it further. We have cos A in the denominator and 1 plus sine A in the numerator. We have 1 minus sine A here, and this is 1 in the denominator, and so we essentially have to multiply this and this. A plus B into A minus B. Use that identity. That will give you A square minus B square. And in the denominator we have cos A. Now 1 minus sine square A upon cos A is what we've got. 1 minus sine square A. Remember the relationship between sine and cos. Sine square A plus cos square A is equal to 1. So 1 minus sine square A is equal to cos square A upon cos A. Cos A, this square gets cancelled. What we are left with is cosine of A. And that's our answer. This is the answer. Okay? Let's move on to the next question now. Okay, let's move on to question number 13. If a pole 6 meters high casts a shadow this long on the ground, then the sun's elevation is what? Let's draw the schematic first. There's this pole here. There's the sun somewhere here. Okay. The pole is 6 meters high. So let me draw it like that. Okay. And it casts a shadow to root 3. So how will the shadow look like? See, the sun's rays are going to fall like this. And this would be the shadow. Okay, so here these rays will be blocked, so the shadow will look like, let me use blue color to represent the shadow. So yeah, this is your shadow. This is how long the shadow is. Let's write down the measurements once. This pole length is 6 meters. The shadow length is 2 root 3 meters. The sun's elevation, that's what we have to find out. So we have to find out this angle, this theta. If you know the perpendicular and the base, which trigonometric ratio comes to mind? Tan of theta is equal to perpendicular upon base. Perpendicular is 6, base is 2 root 3. This is what tan theta is. This is what is going to give me the elevation. Okay, we have 3 upon root 3, which is root 3. I hope you all can calculate this. Okay, 3 can be written as root 3 times root 3. So in the numerator we'll have root 3 times root 3. In the denominator we have root 3. 1 root 3 will get cancelled and we'll be left with root 3. When is tan theta root 3 equal to root 3? When theta is equal to 60 degrees. So this is our answer. Let's move on to question number 14 now. If the perimeter and area of a circle are numerically equal, then the radius of the circle is, I do not know the radius, so let me assume it to be r. It's saying that the perimeter is equal to the area, the numerical value. Of course, the units are not going to be the same. That's why you can't say that perimeter is equal to area. That's why the question is saying they are numerically equal. The number is equal. Okay, what's the expression for perimeter? Expression for perimeter is 2 pi r, and for area is pi r square. From here you find the value of radius. Okay, so this and this r gets cancelled out, pi and pi gets cancelled out. This gives you r is equal to 2 units. Simple enough. This is your answer. Let's move on to question number 15. It is proposed to build a new circular park equal in area to the sum of areas of two circular parks of diameter this much in the locality. Okay, so we have to build a new circular park, and the area of that new circular park has to be the sum of areas of two smaller parks. This is what is given to us. The two smaller parks have diameters, so one has diameter 12 meters, the other has 16 meters. Okay, so the area for this would be pi radius square. Remember, radius is going to be diameter by 2, so 12 by 2, that is 6. That's this area. The second area is pi times, again, the radius square. Half of 16 is the radius, 8 square. Okay, all right. We have to build a new circular park, a bigger one, and the area of this is the sum of areas of these two. So pi 6 square plus 8 square. This is the area. Okay, so let's assume the radius of this bigger circle to be capital R. So the area can be represented in terms of this radius this area can be represented as pi times r square. And we've already seen that this is pi times 6 square plus 8 square, isn't it? 6 square plus 8 square. So pi gets cancelled, and from here you can find out that r is equal to 10. How? If you remember Pythagorean triplets, 6, 8 and 10 would be Pythagorean triplets. So if you can't remember 6, 8 and 10, I'm sure you remember 3, 4 and 5 as the Pythagorean triplets. 3, 4 and 5 as the Pythagorean triplets. 3, 4 and 5. Now if you remember this, from extension, 6, 8 and 10 will also be Pythagorean triplets, and that's why I figured out directly without even calculating that it has to be this. The answer to the 15th question is option number A. Let's move on to question number 16 now. So we have a square board. The side length is given to us. It's 2A. And it is circumscribing a circle. It's given a red circle, but I don't see any colors here. It's a mistake in printing. But yeah, it is circumscribing a circle. This is a person, Jaydev. He's asked to keep a dot on the above said board. The probability that he keeps the dot, so the dot can be, it's a marker. He has to keep the marker on the shaded region. Now, what is the shaded region here? This part is the shaded region, okay? This part. This part. This part is the shaded region. Yeah. Let me delete that and rewrite the dimensions once more. So this length is 2A, and I'm sure you all note what is the shaded region. It's the regions outside the circle but inside the square. Those are the shaded region we are talking about. What is the probability that the dot falls in this region? I'm sure you remember areal probability, like probability calculated with the help of areas. Areal probability. The probability that the dot or the marker falls in the shaded region is simply area of the shaded region upon the total area of the board. So probability P is equal to area of shaded region upon area of the square shaped board. Square board, okay? Now we all know the area of the square. Since the side length is 2A, we can directly write 2A into 2A. So we know the denominator, right? 2A into 2A, A square. So that's, now we have to find out the area of the shaded region. Area of the shaded region is equal to 2A's whole square, which is the area of the bigger area of the square, minus the area of the circle. So the area of the circle. Pi, what would be the radius of this circle? Can you think a little? It's going to be A. So pi A square. That's the area of the circle. Let's simplify this quickly. 4A square minus pi A square upon 4A square. This is my probability. A square gets cancelled from the numerator and denominator, and we have 4 minus pi on the numerator side and 4 in the denominator. So 4 minus pi upon 4. This is option number B. That's your answer. Okay. Let's move on to question number 17 now. Two cards of hearts and four cards of spades are missing from a deck, from a regular deck. Two cards of hearts. Hearts are red in color. I'm sure you remember that. All hearts cards are red in color, whereas all spades are black in color. Okay? Are missing from a pack of 52 cards. So, two cards and four cards. Total 6 cards are missing from 52 cards. How many total cards do we have here? How many total cards do we have? 52 minus 2, that is 50, and then 50 minus 4, that is these many cards. Okay, so just by looking at the total cards, you will be able to at least remove two options. So now you have to figure out which of these options, B and D, are correct. So yeah, let's look at the probability part now. A card is drawn at random from the remaining pack. That means from a pack of 46 cards. What is the probability of getting a black card? My next question to you is, how many black cards are there? How many black cards are left? How many black cards are left? Originally, two suits are of red, two suits are of black. Or in a regular deck of cards, there are 26 black cards and 26 red cards. We all know that. 4 black cards are missing, we see that. So this is equal to 26 minus 4, that is 22 black cards. These many black cards are there. So what's the probability then? The probability is going to be, let's use this, okay. So total cards is equal to 52 minus 2 plus 4, that is 46 cards, right? Total black cards remaining, or let's write just black cards remaining because total will be confusing. Black cards remaining. How many black cards are remaining? Originally there were 26 black cards, and from there we lost 4 black cards, as we can see here. So 22 cards. What's the probability of getting a black card from a deck of 46 cards if there are 22 black cards inside it? The probability is 22 upon 46. That's the answer. Let's quickly move on to the next question. Question number 18. Now, this is a question on statistics, mean, median, and mode, specifically on modes. Yeah, let's try to attempt it. The upper limit of a modal class of the given distribution. So first of all, we have to find the modal class. Now, modal class can't be found out if we do not have proper class intervals. Right now, we do not have proper class intervals. So we'll have to rewrite this data into another table. So we have to make class intervals of height. So something like 0 to 140, then 140 to 145, 145 to 150. These are the class intervals basically that we will have to make. Yeah. So what are the class intervals then? 145 to 150, 150 to 155, 155 to 160, and 160 to 165. These are the class intervals. So how many how many girls are below 140? So from 0 to 140, it's directly given. Let me just fill out the data. 4 girls are below 140 centimeters of height. Below 145, how many girls are below 145 centimeters of height? Total 11 girls. That's what this data tells me. But we already know from these 11 girls, 4 are below 140. So how many girls are between 140 to 145? Once again, please listen to this carefully. There are a total of 11 girls below 145 centimeters of height. That means from 0 to 145 centimeters of height, there are 11 girls. But we know that from 0 to 140 centimeters of height, there are 4 girls already. So how many girls are between 140 and 145? 11 minus 4, isn't it? 11 minus 4, so I'll write it directly. From 145 to 150, how many girls are there? We know that from 0 to 145 there are 11 girls. So from 145 to 150, we will have 29 minus 11 girls. Similarly, 150 to 155, I'll have 40 minus 29. Here I'll have 60 minus 46. And here we'll have 51 minus 46. Let's calculate this. So this is 4. Let me use another color, okay? This is 4. 11 minus 4 is 7. 29 minus 11 is 18. 40 minus 29 is again 11. 60 minus 46. Well, 60 minus 40 is 20. 20 minus 6 is 14. And 51 minus 46, we have 5. So, this is the frequency. If you have to find which one is the modal class, that means you have to find where, in which class interval is the frequency highest. The frequency is highest in this class interval. And what's our question? The question is, we have to find the upper limit of the modal class. This is what we have to find out. So we have figured out what our modal class is, which is this. Can you tell me what is the upper limit of the modal class? The upper limit of this modal class is this number 150. Okay, this is our modal class. So that's how we find the answer to question number 18. Let's move on to question number 19 now. This is an assertion reason type question. In these type of questions, there's a statement, a claim which is made, and then there is a reason or explanation for that claim. We have to figure out whether the claim is correct, whether the reason is correct, and whether the reason is the correct explanation of the assertion, where the reason correctly explains the assertion or not. Let's look at the statements one by one. Statement 1 says the total surface area of the top. This is the entire top. Top in Hindi it's lattu. Or in other languages you may know it by different names. So this is something which kids play with. Yeah, it rotates with high rotational velocity. So that's the top we're talking about. Do not confuse it with the top view or the top section of anything, okay? It's noun, top. All right. So the total surface area of this top is the sum of the curved surface area of the hemisphere, okay? That means the curved surface area of this hemisphere and the curved surface area of the cone. The curved surface area of the cone. So in 3D, you have to imagine the curved surface area of the cone and the hemisphere. The assertion seems to be true, okay, because that's what is exposed to the air outside. And if you have to find out the total surface area, so assertion is correct. It's pretty simple. What about the reason? The top is obtained by joining the plane surfaces of the hemisphere and cone together. So they're talking about this part. You know, this is the plane surface of the hemisphere. Similarly, this is the plane surface of the cone. Now, if the plane surfaces are joined together, is any part of the plane surface exposed? It's not. So it won't be counted in the total surface area of this top. So the statement made in this part, the statement which is given as reason, seems to be the correct explanation of our assertion. So the correct answer has to be both these statements are true and this is the correct explanation. So I would say this is the answer. All right, let's move on to the final question. So there's the assertion is now we're talking about question number 20. Okay, the assertion is that these sequence of numbers are in arithmetic progressions. We can validate this. You just figure out the common difference. Is the common difference consistent? Is it constant? So second term minus the first term. What is the common difference? It's 5 by 2. Third term minus the second term. What's the common difference? This minus this. Again 5 by 2. 5 by 2 minus 0, again 5 by 2. So we can see that the common difference is fixed. This is in arithmetic progression. So assertion is correct. Assertion is correct. This statement is correct. What about the reason? The reason says the terms of an arithmetic progression cannot have both positive and negative rational numbers. What kind of statement is this? This is not true, certainly. An arithmetic progression can have both positive and negative numbers. There's no harm in that. So yeah, this statement then is not correct. Reason is wrong or reason is false. That means reason is false, assertion is true. Option number C is our answer. With that, we have finished solving section A of our question paper of the sample paper. Section B onwards, students, these solutions are given in detail on the CBSE website itself. I'll share the link in the description. You can go to that page and see the solution for yourselves, okay? But in case if you want me to explain some of the questions that appear after this, do let me know in the comment section. I'll tackle those questions one by one. I'll select a few depending on what is the demand, and then I'll explain it to you. So we are going to end the session now. Thank you so much for joining. Make sure to check out the link where you will find the solution to all the questions from section B, section C, D, and E. Okay. Thank you so much for joining. I hope this session was helpful. Thank you so much. Bye-bye.